it needs to be a multiplication then. All right, moving right along, we're getting into division now. In division, make sure the total is first. We're always going to have a total in our division problems, similar to our first type of multiplication problem, but in division we always have a total, and that total always has to be your first number, because we always take the reciprocal of the second number. We're never going to take a reciprocal of a total. And some keywords: equally, shared, and again, each, but that each is going to be in the question. And we're going to see two examples of division word problems too. Type 3 is when you're dividing by a fraction less than 1, you're going to get a bigger number. But when you're dividing by a fraction greater than 1, you're going to get a smaller number. That's very important to keep in mind. When you're dividing by a fraction less than 1, you're going to get a bigger quotient. But if you're dividing by a number greater than 1, like a mixed number, you're going to have a smaller number, a smaller quotient. All right, we have 4 problems left. Let's power through these. The guests at the party shared 5 pies equally. If each person got 1/8 of the pie, how many guests were at the party? So, I'm looking at this problem. I see like lights and sirens going off all over the place. I have shared, I have equally, I have each in the question. Flashing lights and sirens going off all over the place. I know this is a division problem. And I'm dividing my 5 total pies, so I have my total, into 1/8. So, let's look at my picture. I have my 5 pies. I'm going to divide them into 8s to feed all of my party guests. Ooh. Pardon my dividing into 8s here, folks. So how many people can get pie? If you count all of these up, you're going to get 40. So let's see if that's it. 5 divided by 1/8 equals 5 over 1 times 8 over 1, finding that reciprocal, making sure my total number of pies is first, equals 40 over 1, or 40 guests. And that makes sense because when I'm dividing by a fraction less than 1, my quotient is going to be larger than my total. My quotient is going to be larger than my total because I divided by a fraction less than 1. I'm breaking my 5 pies up into 1/8 of a pie. There's going to be more than 5. I'll actually be able to have 40 guests. And you can just think about it. If by some weird coincidence you multiply, you would get 5/8 guests. 5/8 guests. How many guests were at the party? Can we have 5/8 of a guest? No, we can't. We can have 40 guests at our party, though. Make sure you're picking the more reasonable answer. And this problem, my favorite. Because if we look in the problem, Archie can walk 1 mile in 1/3 of an hour. How far can you walk in 3 hours? Do we have any keywords there? No, we don't. We don't have any keywords there. But we can look and see 3 hours. That's our total. 3 hours is our total. And we're dividing that into 1/3 of an hour. 1/3 of an hour, which is less than 1. So we know we'll have a bigger answer. So I have my 3 hours here because our picture is always going to show our total. He has 3 total hours. I'm going to divide each one into thirds because that's what we know how far he can walk 1 mile in. And each one of these will be 1 mile. So that looks like 9 miles. Let's find out. 3 divided into 1/3 equals 3 over 1 times 3 over 1 equals 9 hours. Would you look at that? It's holding true so far. Our quotient is larger than our total because we're dividing our total into fractions less than 1. These hours, each one of these hours, is getting smaller. It's going down into 1/3 of an hour. So that's broken down into 9 parts. In each part, he walks 1 mile, so that's 9 miles. Moving right along. Type 4. We're almost there, folks. Type 4, we're dividing by a fraction greater than 1. Woo! All right. A relay race is 1/4 mile long and is run by 4 member teams. If each team member runs the same distance, what fraction of a mile does each team member run? We have our total. 4 is greater than 1. So now our quotient, if you remember, is going to be smaller than our total. And not only do we have an each 1 time in our question, but we have an each 2 times in our question. That means we are dividing. And you can look, you can do this 2 different ways. If here is the start and finish, because if this all is 1 mile, the race is only 1/4 of a mile, so it's start and finish. So if it's broken down into 4 parts for each member, 1 for each member, each one of these would be 1/16 of a mile. And you don't need a number line. You can make it just normally too. And each one of these is broken down into fourths. Each part of that is 1/16 of the whole mile. And if we look, 1/4 divided by 4, 1/4 of a mile divided equally amongst 4 team members equals 1/4 times 1/4 equals 1/16 of a mile. Last one, folks. You try this one. It's dividing a fraction by a fraction greater than 1. Try it. See what you get. Fill out your picture. And come back with an answer and a filled out picture. 3, 2, 1, pause. All right, folks. So we have a challenging problem here because they give us that they ate 2/3 of the pizza and took the rest home. The next day they shared the leftover pizza equally with their daughter. So how much total pizza was shared? They ate 2/3, so we have 1/3 left over. 1/3 is our leftover. That's our total. And Kelly and Brian are sharing it equally with their daughter. So we're not dividing by 2, we're dividing by 3. So this 1/3 of a pizza that's left over gets divided into 3 equal parts. 1/3 divided by 3 equals 1/3 times 1/3 equals 1/9 of the pizza. Okay, folks, as you move into your practices, you have this great guide here in your notes to help you try and figure out whether or not a problem is multiplication or division with fractions. If you still have questions, please try and come find me, flag me down. I will be more than happy to help you. If you do not have any questions, or you want to give it a go on your own with your notes, go on into your practices. Great job today, folks. I know this is a doozy, but for now, this is Mr. Tennell signing off.